Welcome to the new episode, and today we are going to learn how to work with Doubly linked list. In our last lessons, we worked on single linked list in detail. I hope you have learned all the parts that we discussed so far, because if you learn those parts, that means you already know how to work with Doubly linked list. Doubly linked list is not something new. A doubly linked list is a type of linked list in which each node contains three parts. The one part is the data, one part is the pointer to the next node, and the third part, which is like extra from the single linked list, is pointer to the previous node. It is the only difference between single linked list and double linked list. So if you know how to work with single linked list, that means you can work with double linked list even easier than single linked list, because here you have a pointer to the previous node also. If you remember from the single linked list, uh, some operation accessing the previous node was one of the difficult job, and then we had to use like a separate pointer just to keep track of the previous node. But with double linked list, every node already access to the previous node, so it is even easier to work with double linked list. So once let's show in example in Java programming to see how it works. As soon as you learn how to set the classes, that means you can work with double linked list similar to single linked list. So if you remember from the single linked list, I said when you want to represent single linked list in programming, you need two classes. One class to represent the node, and another class to represent the linked list class itself. And the linked list class was actually just the head pointer, which was pointing to the first node. And then we were able to write all other methods in the linked list class. So similar to that, with double linked list, we can do the same. So we can have one class to represent our node. Let's name it node. And each node has three ports here. With single linked list, each node had two ports. One port was the data, and the other port was the pointer to the next node. But with double linked list, we have three ports. Let's see the single okay. So here you see we have only two properties for the node that we were using in single linked list. One was the data and one was a reference to the next node. But here with the double linked list, we have three ports. One is the data, one is a pointer or reference to the next node. So data right now you see is integer, not of type node, integer. One part is next, and the other part is the previous pointer, node previous. It is the extra part that makes your job much easier to work with in double linked list. So let's initialize them. Public node. Actually, by default that's public, so you don't need to write public every time. Node. So every time that you create the object of this class, you pass the value, init value. So data equal, and you pass that value to this variable, to data. Next is null by default. previous is also null by default. Okay, so now it is your node class with double linked list. You have one extra part, one additional part that helps you work with double linked list much easier. So now create our linked list class also. Linked list, finish. Okay, so in our linked list, in single linked list we had only one property, which was pointing to the first node. But with double linked list we have two properties. One points to the first node and one points to the last node, which this is very helpful. So node head and node tail or last. So now let's initialize them. Linked list. So head is null by default and tail is null by default. Okay. So now let's see in an example how this tail is helping us and how this previous pointer is making our job easier. So I will work as an example only how to insert a new node at the end and how to insert a new node at the head and a new node at the end on both tails, on both sides, on both ends. So let me first explain that visually, then we can do that. Duplicate. So now let's say that I have this new node and I want to insert this at the head of this list. So when you say that you want to insert this new node at the head of this list, what does this mean? If it was a single linked list, you are saying that, well, the head has to point to this new node and this new node has to point to the current head. That is same thing here with double linked list. You want this node to be the head, this node to be the head. So if this node has to be the head, that means this head has to point to this one, and so it has a next and previous. The next has to point to the current head, and the current head, it has a next and previous. Right now the previous points to null by default, but after this time it has to point to this new node. So, and the new node dot previous points to null. As simple as that. Now let's write that in the method, how we can write that code for that. So public void insert at the beginning. Okay, so pass the value when you are creating your object. Okay, so first create the object node, new node equals new node, pass the value. So the new node is created. It is the new node. Now what do you want to do? So you're saying that, well, this new node, it has a next pointer and it has a previous pointer. So you're saying that the next has to point to the current head. Okay. So before doing that, let's check an edge case. Sometimes your list can be empty. If your list is empty, so you don't need much operation, that means the new node that you have created, that is the first node and that is the last node. Actually, that is the only node in the class. So that is much easier to check if the list is empty or not. You are saying that, and how you want to check if the list is empty, you check the head. If head is still points to null, that means the list is empty. But if head is not pointing to null, that means there are elements, there are some nodes in the list. So you say if head equals to null, it shows the list is empty. So you are saying if the list is empty, then head equals to tail equals to the new node. That new node can be the head and can be the tail, and that is the only node. That's as easy as this. But if it is not null, that means there are some nodes in the list. So at that time, we have to set all these references correctly. So first time you are saying that, well, the new node, the next property, the next pointer has to point to the current head. So you are saying that the next property of new node has to point to the current head, and it is the current head. So you are saying that new node dot next has to point to the current head, and the current head dot previous has to point to the new node. Right now it points to null, but you are saying that, well, after this time you should not be pointing to null, but you should be pointing to the current, to newly created node, like this. So you are saying that head dot previous has to point to the new node, like this. And at the end you are saying that, well, after this one it is not the head. You are saying that, hey head, you have to point to the new node. After this time it is the head. Okay, you are saying that head has to point to new node, something like this. And of course the previous pointer of the new node, it points to null, like this. See, you inserted a new node at the head of the double linked list. Now let's insert a new node at the end of the list. So if you have one more node, so you want to insert this node at the end of this list. So if you remember from the single linked list, if you had to add a new node at the end, you had to start from the head and traverse the list, and you had to find the last node. Then you are able to say that, hey, last node, up, instead of pointing to null, point to the recently created node. But with double linked list, you already access the last node, so you don't need to start traversing this list from the head. It is similarly to adding a new node at the beginning of the list. Like you have at the beginning, you have access to the head, and at the end you have access to the last node using this tail property that you have here. So now let's visually first solve this. What does it mean? This means that the current last node, which we have access to this using the tail, we are saying that instead of the next value, instead of pointing to null, it has to point to the recently created node. And this new node, the previous, it has to point to the current last node. And the tail has to point to this recent node. So let's write the method for that, how it works. So you are saying that public void insert at the end, okay, init value, it is also insert at the end. So first create the node, the value should be, for example, 80. New node equals new node, pass the value to this. So the new node is created. So here also you can check the edge case, like if the list is empty or not. Because if the list is empty, again, you can insert as simple as this. You don't need to do much operation. And how do you check if the list is empty or not? Again, you can check either using the head or tail, but the common thing is to use with the head. You are saying that if head equals null, that means the list is empty. So at that time, this new node is the head and the tail, everything. New node. That's like this, as simple as this. But if it is not null, that means there are some nodes in the list. So you have to set this reference points correctly. So first you say that, well, this current last node, instead of pointing to null, it has to point to the new node. Let me put this here. So this one, right now it points to null. I'm saying that after this one, you don't need to point to null. You have to point to like this recent node that you have created. So we are saying that the tail dot next, right now it points to null. After this one, we are saying that instead of pointing to null, point to the current node, like this. And the new node, it has a previous property. So you are saying that the previous has to point to the current last node. So we are saying that, hey, the previous pointer has to point to the current last node, because after this one it is previous to this one. So we are saying that new node dot previous has to point to the tail, and tail has to point to the currently new node. It has to point to this. Let me fix it like this. After this one, it is the tail. So tail has to point to the new node, like this. And of course, the next property of this points to null, like this. So it was as easy as this. See, now that you have the access to previous node and you have access to the last node, like insertion is as easy as insertion at the end is as easy as insertion at the beginning. Similarly, you can use this previous pointer anywhere in the middle. Like you can traverse the list backward and forward. So it is much easier to work with double linked list rather than with single linked list. But you have to first visually solve the problem, because if you do not take care of the problem visually, there is the possibility of like mixing them. So I hope you got a general concept of double linked list, and that was all for today. But if you have any specific questions, you can add your questions in the comment section. I will check your questions and I will solve them as well. Until the next lesson, have a nice time, everyone.